guys, I'm Archana from Edureka and I welcome you all to this session on unit testing. But before we proceed, let's go ahead and take a look at the topics which we will be talking about in today's session. We will begin the session by discussing different levels of software testing, and then we will move on to our today's topic, which is unit testing. There, we will learn what unit testing is, why unit testing is really important. After that, we will do a small demo on how to write simple and easy to understand unit tests. And finally, we will end this session by talking about best unit testing frameworks available in market. So I hope agenda was clear to you guys. Let's get started then. Before software is released to market, it undergoes rigorous testing. I'm sure you guys know that. Testing is an integral part of any successful software project. Software testing basically is the process of executing the software or any sort of application to find out if there are any bugs or some sort of errors in it. So before software actually goes public, programmers spend hours trying to find out every bug there is. They check for any mistakes and problems in the design and the functionality of the software. Until then, product won't be available for commercial use in the market. So guys, there are 4 main stages of testing. So you need to perform this testing, only then you can say that your product is ready for the market. Those 4 levels are unit testing, integration testing, system testing, and acceptance testing performed in the same order which I mentioned just now. So the first level of testing is unit testing. It's the micro level of testing. It involves testing individual modules or pieces of code to make sure that each part or unit is correctly working. A unit can be a specific piece of functionality. It can be a program or a particular procedure within the application. It can be anything you want. Unit testing helps verify internal design and internal logic and internal parts, as well as error handling. So that's unit testing, your first level of testing. After unit testing, we have integration testing. Integration testing is usually done immediately after unit testing. This level tests how the unit works together. Individual modules are combined and tested as a group. It's one thing if unit works well on their own, but how do they perform together? Integration testing helps you determine that and also ensures your application runs efficiently without any error. And lastly, it identifies interface issues between modules as well. So there are a few techniques that can be used for conducting integration testing. For example, you have something called Big Bang testing, top-down approach, bottom-up approach. Well, I'm not going to discuss all that here because they're out of scope of this session. Our main focus is on unit testing. After integration testing, the next level of testing is system testing. So as the name actually implies, all the components of software are tested as a whole in order to ensure that overall product is working properly as you expected. System testing is particularly important because it verifies the technical, functional, and business aspects of your software. There are dozens of types of system testing. For example, you have usability testing, regression testing, functional testing, and many others. Well, if you want to know more about these type of testings, you can refer to the software testing playlist in Edureka YouTube channel. Moving on, this system testing is typically done by testing team and includes a combination of automated testing as well as manual testing. And final level of testing is acceptance testing, or UAT we call it. That's user acceptance testing. It determines whether or not the software is ready to be released. Let's face it, requirements keep changing throughout the development process, right? You agree with me, right? It's important that user verifies the business needs are met before the software is being released into production. So are the functional requirements met? Are the performance requirements met? These are the questions that are answered during this level of testing. UAT, or user acceptance testing, is the final say to whether the application is ready for the use in the real life or not. So guys, these are 4 levels of software testing. Each level of software testing has a particular purpose and provides value to the software development cycle. Some levels are their own type of testing. For example, unit testing includes just that, unit testing. But integration testing can include many types of testing. So guys, you can't mix up these levels as you want during development stages. There's a logical sequence that you should stick to in order to minimize the risk of bugs cropping up just before the launch date of your software. In today's session, we will be discussing particularly about unit testing. But before we get started setting up our environment and writing any code, let's define exactly what unit testing is, why is it worth doing, and how to get started in incorporating it in our software projects. So let's get started there. So the most basic type of testing is unit or component testing. The goal of unit testing is basically to segregate each part of the program and test those parts individually to check if they're working properly or not. So it isolates the smallest piece of testable software from the remainder of the code and determines if it behaves exactly as you expected and according to your requirements or not. Generally, those small pieces of software that I've been telling before are usually referred to as unit. So this unit can be almost anything you want it to be. It can be a line of code, it can be a method or a class or some sort of program or a part of application program, anything. But smaller the unit is, it's always better. Smaller tests give you much more granular view of how your code is performing at basic level. There is also the practical aspect that when you test very small units, your test can run very fast, like 1,000 tests in second fast, that fast. Well, here's a simple example to help you understand what a unit can be or how unit testing is. So consider this simple code. Well, I have a simple function or method here. The function, as you can see, the main function, it's performing division operation. It's accepting two parameters a and b, and it's returning the value that you get after dividing a by b. And next comes the testing function. As you can see, the testing function is written in Ruby. Well, the language doesn't matter. The language, whichever you're comfortable with, you can use that. Anyway, as you can see, I have two variables, a and b, and I'm assigning values 6 and 2. And in the assert equal function, I'm calling the divider function. And I also have the first parameter, which is the value which I'm expecting that the division function should give it to me. So the value which I'm expecting is 3, and I'm passing the function and parameters to that function. So after dividing a by b, which is 6 by 2, I get the answer 3. And assert equal functions tells me that 3 and 3, the expected answer and the actual answer I got are the same. So my function is working properly. Well, this is a positive case. You can also do that with the negative case, as in you can just change the 3 expected value to 4 and see if the assert equal function returns you the actual answer. It says that your test fails. It means that the expected answer and the obtained answer are not the same. So that's how you perform a testing on small unit, which is a part of your entire program. So here the small unit is division function. So like I said, a unit can be almost anything you want it to be. It can be a line of code, or it can be a method, or it can be a class. So this is very basic example, but I'm sure it gives you an idea of unit testing, right? So guys, unit testing is usually performed at the earlier stages of development process, like I said earlier. In many cases, it is executed by the developers themselves before handing the software over to testing team. One of the biggest benefits of this testing is that it can run every time a piece of code is changed. So that way, you can resolve if there are any errors very quickly. And since you're dividing your code into modules here, you can reuse your code and testing becomes much easier and efficient, and your product is well versed in the market. Now to understand unit testing better, let's go ahead and see a simple algorithm. So you start writing your test. So you add your test to the test suite. Then you run the unit test. If the test passes, then you add one more test or add it to the next level of testing. In case your test fails, what you do, you make the necessary changes and you run unit test again. And after you run your test again, if it fails, then you make changes again and you repeat the cycle until the code which you've written is perfectly working and it's returning the value that you're expecting or the results that meets your requirement. And suppose after making changes, if your test passes, then you can add it to the test suite and move it on to the next level of testing. So once you're sure that all your tests are working properly, it means your test suite is perfect and your product is working properly. You can stop unit testing and perform next level of testing. Very simple, right? This type of basic testing offers a lot of advantages, guys. Unit testing provides numerous benefits, including finding software bugs, facilitating change, simplifying integration, providing a source of documentation, and many others. So let's take a look at them right now in more detail. So here are the benefits of using unit testing in software development cycle. So first of all, it makes coding process more agile. When you add more and more features to software, you sometimes need to change old design and code. I'm sure you agree with that. However, changing already tested code is both risky and extremely costly. If we have unit tests in place, then we can proceed for refactoring very confidently because we know that each part of our code is working properly. So code completeness is very important in software testing, especially agile process. So running unit tests can demonstrate code completeness. So unit testing makes code practice more agile and very simple. Secondly, unit testing improves the quality of your code. It identifies every defect that may have come up before the code is sent further for further testing. So writing tests before actually coding makes you think harder about the problem. It exposes the edge cases and makes you write better code. Also, the code that you've written is since divided into modules, it becomes reusable. This means that codes are easier to reuse when you perform unit testing. Unit testing also helps find software bugs early. Since unit testing is usually carried out by developers who test individual code before integration, issues can be found very early and can be resolved easily without impacting other pieces of code. So, the advantage of detecting any errors in software early in the day is that by doing so, the team minimizes software risk and avoids spending too much money and time. Unit testing also facilitates changes and it simplifies integration. It allows programmers to refactor code and upgrade system libraries at later date and make sure that the module still is working properly. Unit testing helps with maintaining and changing the code. It reduces the defects in your newly development or the newly developed module of your code. It reduces bugs when changing the existing functionality as well. Unit testing actually verifies the accuracy of each unit. Afterward, the units are integrated into an application by testing parts of the application via unit testing. So basically, it makes integration much more better. It provides documentation to developers. So code documentation is basically drag and it shows mostly how little code documentation gets written. Unit testing can make the documentation burden a little easier by encouraging better coding practices and also leaving behind the piece of code that describe what your program is actually going to achieve. Unit testing also makes debugging easier and quicker. It helps simplify the debugging process. If a test fails, then only the latest changes made in the code need to be debugged. It's easy, right? It helps create better software designs. Writing the test first forces you to think through your design and what it must accomplish before you actually write the code. This not only keeps you focused, it also makes you create better designs. So that way you're sure that the code you write will perform the right thing at the right time. And lastly, it reduces testing costs. Since the bugs are found early, unit testing helps reduce the cost of bug fixes. So just imagine the cost of bug found during the later stages of development. You will have to modify the entire code of your project. That sounds really tiring and waste of money. So performing unit tests saves you a lot of money and effort on your part. So guys, these are a few benefits of regression testing. I'm sure there are others as well. Make sure you research on it and learn more about them. So there we go guys. I hope you're convinced as to why you should use unit testing. So we have covered the basics of unit testing. If you have any queries regarding what we have discussed till now, please do post them in the comment section and we'll get back to you as soon as possible. So moving on, let's do a simple demo on how to write unit tests. But before diving into the main part of this tutorial and writing unit tests, let's quickly discuss the properties of a good unit test. Unit testing principles demand a good test is easy to write, it's easily reliable, it's readable, and faster and efficient. So easy to write. Developers typically write a lot of unit tests to cover different cases and aspects of application behavior. So it should be easy to code all those test routines without much effort. It should be readable. The intent of unit tests should be clear. A good unit test tells a story about some behavioral aspect of your application. So it should be easy to understand which scenario is being tested. And if the test fails, it should be easy to detect the bug without actually going through the entire program. That's how easily readable your unit test should be. So with a good unit test, we can fix a bug without actually debugging the code. Then it should be reliable. Your unit test should fail only if there's a bug in the system under the test. Well, the thing is, programmers often run into an issue when the tests fail even when no bugs are introduced. So good unit tests should be reproducible and independent from external factors. Lastly, you write your unit tests so that you can repeatedly run them and check that no bugs have been introduced. If your unit test is slow, it will affect the final product. One slow test won't make a significant difference, but add 1000 more and we're surely stuck waiting for a while. Slow unit tests may also indicate that either the system under the test or the test itself interacts with external system, making it environment dependent, which is not a good thing in unit testing. So that's it guys, there are no secrets to writing unit tests, so let's go ahead and write one. So guys, before we actually start with the simple demo, there's certain things which you should know. First of all, to perform this demo, you need IDE. It could be your Eclipse or IntelliJ, anything that you're comfortable with. And you need a unit testing platform, or you can say framework. In here, in this demo, I'm using a framework, a popular framework for Java called TestNG. There's another one called JUnit. You also have different frameworks for different languages that you can use. We'll discuss about the unit testing frameworks later. But as for in this demo, as you should know, I'm using Eclipse IDE and I'm using TestNG for my unit testing framework. So that's all you should know. And regarding how you should install TestNG, there are different ways you can install it using Maven. The easiest way in Eclipse is you can actually install it using Eclipse Marketplace. Well, you have help command here. You can see the menu. You can go for Eclipse Marketplace here and click for TestNG and just click on install. After you've done that, to make sure it's installed properly, all you have to do is go for show view here and click on other. And under Java, make sure that you have TestNG installed here. If it's showing TestNG here, it means that installation has been done properly. So that's all, guys. I've already written program. Well, it's a very easy program. As you can see, I have a math function first of all, and it has one method which adds two numbers. So it's returning int value, and I have first parameter and the second parameter, and I'm adding, and I'm returning the value to my testing function. So this is my basic function, and I have a test function which is conducting the test here. So as you can see, I'm using annotations here and importing this because to perform test, since I'm using TestNG, I need to import these details. So I'm using annotations, which is at test. This is called what we call annotations. And I'm using a method called assert equals. So I'm importing that as well. So again, this class contains a single method, which is adding two numbers. I have two variables here. One is expected and the actual. Expected is the one which you want the method to return to, and the actual is the one which actually the method returns to you. So as you can see, the expected value, I'm giving it as, let's say, 4. And as for the actual value, I'm using a math add function, which I've created here. As you can see, I have add function here. And I'm sending two parameters, which is 2 and 2. So if I go back to function, since I'm calling this function, the parameters here will be first is also 2, second is also 2. So 2 plus 2, it should return 4. And here I have a method assert equals. This is the actual value which I'm getting from the math function, and this is the expected value which I've given it 4. And since both are 4, the test should result success. Let's go ahead and check it. It's as easy as that, guys. So this is one unit of your entire program. You can keep adding units in this way. So first we're checking if this unit is working properly. For that, let me run the test. As you can see, it says this test has passed and the test run 1, failure 0, skip 0. It works, right? Let's go ahead and check another further values. Let's say, let me give it as -4 and -2 plus 2. That should be, let me just give it as -3. So -2 plus -3 should be -5. Now if I call assert equals function, the expected value is -4 and the actual value is -5. So the test should return failure. Let's go ahead and check it. So here, as you can see, it's giving a long message. It says this test is failed because expected value is -4, but the actual value is found to be -5. And as you can see in the default test, one test was run. You have one failure and 0 skips. That's it, guys. And now let's make it a little more bigger, as in let's add one more function. In the math function, I have a multiply function here. So let me go ahead and add it. So I'm not negating or I'm not commenting the add function. Let it be there. It's going to give us result for both the functions here. So this multiply function, again, it's taking two parameters. One is multiplicand and one is multiplier. It's multiplying them and returning the answer to us. Let's go to math Java test. Here, I don't have a test annotation for that, right? So let's go ahead and write one. So public void multiply two numbers, return sum. Any name of your function could be according to your wish. And here I go. So final int expected. Let's give it 4. Let's keep it simple for a while and then we'll make it complicated. Final int actual. So multiplicand, let's give it as 2. And the multiplier also, let's give it as 2. Assert equals actual and expected. Okay, let me save it. So obviously the add function, it should result a failure, and multiply, it should return the correct value. So let's go ahead and test it. So as you can see, 2 tests are performed, 1 failure. So let's go ahead and see. It says multiply two numbers has successfully passed. but add has failed because expected value is -4, but it was found to be -5. So that's how you write unit test. Let's make it -4 and check if it's working for the negative numbers as well. As you can see, it's showing two failures here. Both our multiply function and add functions have failed. So guys, it's as easy as that. First, I wrote a unit test for add function. So that add function is a unit. You can call it a unit, a part of your program. And I've checked, I've tested since the method is working properly. I'm going one step ahead and added one more unit, which is a multiply function. Even it's working properly, then you go ahead and add one more part of or one more unit to your function or the program of your application. So guys, that's how you write simple unit tests. As you can see, the tests were very simple and these are very basic level tests. You can go ahead and explore and make them complicated. So I'm not going to do the divide function. The purpose of this demo was for you to understand how simple it can be and how your unit test should be. Not very complicated. They should be very easy to understand. One look at it, the person who is looking at your code should understand what your code is actually performing. So there you go guys. That's how you write your unit test. Let's get back to the theory part. So I hope you've understood what we did in the demo. Let's move forward and check out the most popular or the best unit testing frameworks to automate unit tests. So the unit testing framework for C# is NUnit. NUnit is a unit testing framework that belongs to XUnit family and it's written entirely in C#. Now as for Java, you have many. The most popular ones are JUnit and TestNG. JUnit is basically an open source unit testing framework for a test-driven development environment. We call it TDD. It supports the core concept of first testing, then coding. This framework is specifically designed for Java programming language. In this, data is first tested and then it is inserted in the piece of code. So it provides the simplest approach for writing code very swiftly and easily. It also offers annotation for test method identification. As we did in the demo part, we used TestNG and I've showed you how to use annotations and an assert equal function. Moving on. A unit testing framework for C and C++ is MUnit. It's an open source unit testing framework which is designed for software application which is written in C or C++. Well, it's used by both developers and testers for software applications which are written again in C and C++. So next we have unit testing frameworks for JavaScript. As you guys know, JavaScript is the language of web, which is the reason there are a large number of test automation frameworks that support JavaScript. So here's one of the most popular unit testing framework for JavaScript, which is called HTML Units. It is an open source unit testing framework that supports JavaScript and it provides graphical user interface features like forms, links, tables, etc. It offers an open source Java library which contains graphical user interface, less browser for Java programs. It also supports cookie submit methods like get, post, and proxy server. It is used for testing applications that are used within frameworks like JUnit and TestNG. So guys, these are not the only ones which are there in the market. There are many other popular frameworks, but these are the top unit testing frameworks which support different languages. As we discussed, for C#, it's NUnit. For Java, you have JUnit and TestNG. For C and C++, you have MUnit. For JavaScript, you have HTML Unit, JUnit, TestNG, and many others. So if you want to know more about them, you can go ahead and research on them. So guys, with this, we have reached the end of the session, and I hope the session was interesting. Well, if you have any doubts regarding the demo or any theory part, please do post them in the comment section and we will get back to you as soon as possible. Thank you guys.
I hope you have enjoyed listening to this video. Please be kind enough to like it and you can comment any of your doubts and queries and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!